Okay. I think my screen is visible, right?
Yes, sir.
Fine. Okay. So previously, what we have done, we have go through the standard ACL. We had the concept called as standard ACL. Okay. As per the rules, whatever the rules we have conveyed. Okay. First is works in sequential order. Works in sequential order. So whatever the commands we are going to write for ACL, something like 10 or 145, whatever. If you give any deny something IP address and anything, deny permit, okay, anything, it works in sequential order. That is, if you give if the first one is right, it is not going to check the previous one and it is going to ignore the remaining thing. Okay. And second one is all deny statements first. Means if you have two deny statements and two permit statements, first you have to write deny statement. For example, let's say here. So is something then deny 192.168.2.0, another deny 192.168.3.0, and remaining whatever the permit. So as per the procedure, first you have to write all the deny statement. Remaining whatever the things it should be there. And in each ACL statements, you should have one permit statement. Why you should have one permit statement? Because imagine that, for example, okay. So let me show you. Okay. So one permit statement is why, because so here what will happen? So I'm going to block each and everything. For example, this network and this my network not to reach this second network and this network to not to reach this network. But these networks can able to talk to each other. Correct? That right? If I deny from
Yes, sir.
192. So what will happen if you didn't give any permit? What will happen when you're writing the command? Okay, so what will happen here? If you deny 192.168.1.0 network to does not reach 2.0 network, and if you give deny 192.168. For example, a 3.0 network should not reach a 2.0 network, then this is not going to reach this one, and this is not going to reach this one. Okay, so what will happen? As per the ACL rules, it is going to check the first one. Okay, and if it is not matched, it will go for second one. If this guy, if this for example, if 192.168.3.1 guy wants to talk to 192.168.1.1 guy, okay. So if here what will happen? It is going to check the first one. First one it is not going to match. Second one it is going to check the second. Second is not going to match. Here, what will happen if there is no permit or anything as given? It implicitly deny. Okay, it's this packet is not going to. You have to give permit all. Okay, what will happen if any other packets which rather than from 1.0 to 2 dots or this two 1.0 network and 2 to 3.0 network, okay, if they want to tag to each other, any one, okay, if this networks which is going to connect to this network, okay, so you have to give remaining packets allow. You have to allow. So manually you have to allow each and everything. So for example, deny 192.168 1.0 network to reach 2.0 network, and you are going to deny 3.0 network to reach 2.0 network. Then what will happen? If you want to, for example, if the packet 192.168.3.1 packets want to ping to 1.1 packet. So what will happen? It will come to the middle router. Okay, it will come to the middle router. Okay, since our ACL was installed here, okay, what will happen? This packet is going to check here. Okay, but I have written only two ACL statements. So what will happen? It is going to check the first ACL statement. It's going to be it's not going to match that one, and it is going to check the second statement. It's not going to match. Then if it is doesn't match, this packet will be dropped. Remember, it's very important. This packet will be dropped. Okay, that's why you have to do permit any. This permit any option, what it is going to do, if these two doesn't match, remaining packet should be allowed. Got it? Got it? If R1,
Yes, sir. Got it.
R2, R3, this is 1.0, it's 2.0, and it is 3.0 network. If 1.0 network does not want to connect to this one, and this guy doesn't want to connect to this one, then this guy can able to connect to this guy. Okay, if you didn't give permit, okay, what will happen? It only check the two ACLs. If there doesn't match, it implicitly deny. deny the statement. That's why you have to give permit any. If you give permit any, what will happen? Whatever the remaining packets except these two packets, remaining packets will be allowed. Got it? Got it, right? And
Yes,
here,
sir.
when you wanted to add a new rule, okay, you have to add it in the bottom. See what I did now. Okay, first I write two things. Remaining I added at the bottom. So whenever, for example, you already write some ACL 145 like that, you forgot to give permit any. Okay, for that reason, the R3 is can't able to connect it to the R1, or R1 is can't able to connect it to the R3. Then what you're going to do? You are going to enter into this ACL and you have to give the new entities or new statement at the below only, not the above. Remember that one. Got it? And
Yes, sir.
once everything is done, okay, you cannot remove one line from the access list. Very important in standard ACL. What will happen if you want to remove? For example, if you want to remove this 3.0 or 2.0, this statement you wanted to remove, you can't able to log in and you can't able to remove this. You have to delete each and everything and again you have to write. Got it? Once you write, you can add at the end. But once you want, and after that, if you want to make any changes, okay, in between the any statements like that, it's not going to be possible. Either you have to delete the whole ACL statement and write it back. Got it? This is what the disadvantages of standard. Got it?
Yes, sir.
Okay, now there is an disadvantages. Okay, so what happens? Imagine this is my server. Okay, file server. Okay, so this is my server. Okay, this is my file server and this is my something web server. Okay, I just wanted these two guys to, okay, try, they if they try to ping this PC, yes, it has to work. For example, this server has to work for ping. Okay, but I want to deny only FTP server. Got it? Here, what will happen? I wanted to deny only one port, that is only one service I have to block. Okay, then, but the remaining should be access. For example, if you type www, if you try to ping from here to here, yes, it has to work. But when you try to access web page like that, it should not work. Okay, so that is where the extended ACL came. Okay, in extended ACL, it's not only work on source IP address, okay, destination IP address, okay, but also it's going to works on port numbers. So for FTP's port number is 21, or you can directly give FTP, or you can directly give 21 port number. Okay, for HTTP, I just wanted to block a particular service. For HTTP, it's gonna be around like 20, 23 like that. Okay, for HTTPS, it's gonna be 443. Okay, here we can able to, in extended ACL, we can able to block the, okay, destination network with the service, not with the only a single IP address. In ACL, what will happen? In standard ACL, what will happen? For example, in standard ACL and in extended ACL, what will happen? So for example, for an example, what will happen in standard ACL? See, for example, I have FTP service. I have one server that is 192.168.1.1. Okay, and it wants to try to ping to 192.168.2.1. Okay, this is a server. Imagine this is a server. Okay, this has FTP server. Okay, FTP, HTTP, telnet. Okay, and SSH is there. Okay, the same thing will be in here either. This one on this side only. So what will happen in a standard ACL? If you block this server 192.168.1 dot server, the whole thing will be blocked. Okay, including all the services. All the services will be blocked. But to overcome this disadvantage, so once you block this server, whatever the services inside this servers also, each and everything will be blocked. To overcome these disadvantages, we have the extended ACL, where we can, if you want, we can only block the FTP. Okay, remaining HTTP, telnet, SSH is will be up and ping will be up and running. Got it? One. So only you're blocking the only
Yes,
one
sir.
particular only one particular thing you can going to block in extended AC. Got it, right?
Yes, sir.
Okay. Okay, now we'll do one thing. Okay, we are going to do some lab. Okay, where we are going to do some this one deny options. So let me go through this one and I'm going to show you. So I'm going to deny. Okay, http request. Okay, see, I'm going to write it here on notepad. Just a minute. So I'm going to deny. And one more thing, okay, one more thing I forgot to tell you. That is, remember this one. We have TCP. Do you know TCP and UDP, guys?
Yes, sir.
Okay. Inside the TCP, you have HTTP port. See, in TCP, what will happen? TCP, you will get an acknowledgement. That is, three-way handshake will be said. Done. Correct, right? This is a server and this is a client like that. First, it is going to send a hi. Okay. Each guy is going to send a hi. He's going to send a hi plus acknowledgement. Okay, saying that acknowledgement, saying that he is going to send hi plus acknowledge hello. Sorry, hello plus acknowledgement, saying that whatever the hi you send, I've received. Okay, again, this server is going to send the client an acknowledgement saying that whatever the hello, it's three-way handshake will be done. Okay, in TCP. In UDP, it's not like that one. If the server and it is a receiver, it is a request you're going to send, it is their response. Okay, it is, for example, this is for mail ID, Gmail mail ID. When you send a mail, okay, first the three-way handshake will be done. It will send it to the destination, correct, or your WhatsApp traffic. This is like playing the PUBG. Correct, right? So what will happen if you have any internet gone? What will happen? You will be not staying in the same right? You'll be moved somewhere else, right? Correct, right? That
Yes,
is
sir.
what UDP. But in HTTP, what will happen? If acknowledgement will be again, there is no acknowledgement here. Okay, this is slow because you have to do the three-way handshake first. The connection has to be established properly. Then here this is faster. Okay, whatever the request you are going to get, it is going to give the response. Okay, this is the fast. Okay, so here the same thing, we have different types of ports. Okay, we have different types of ports available. Okay, so for TCP, okay, UDP, and we have ICMP. ICMP is the message. Okay, whenever you send a packet, it is going to send an acknowledgement, right? I'll show you. Okay, so here in HTTP will be the this one, telnet and FTP and SMTP, that is mail. It will all come under TCP. In UDP, you will get DHCP, TFTP, and SNMP, request and restore, and DNS will be come here. Here in ICMP, we will get only ping tracer. Okay, tracer is going to trace the request. For example, if you give, here, if you give like, so trace, if you ping from 190 to 160 or 1.12 to 3.1, if you ping from 192.168.1.1 to 3.1, it is going to show from which router I go, from where I have jumped from second router, from there. This is going to trace from where to where I reach to where to where I go to reach the destination. I'll show you that one also. Okay. So now, okay, this is what we are going to do. So if you are using TCP, you have to give the protocol TCP. If you are using UDP, you have to give UDP. If you are using ICMP, we have to give the ICMP like that. Okay. So for let's say, let's go to one example. Okay. And one more thing here, we are going to do another concept called as, okay, operators. OPERATOR, operators. Okay. Here what will happen first? Okay. So I'm going to write access list. Okay. 110 permit any equal to 80. Okay, so what will happen here? Equal means whatever the packet which is coming to the server, whatever the packet which is coming to the server from source to destination, if it is carrying port number 80 and it is matches the server's port number 80, then only it is going to update. Got it? Got it, right? If you send a package to Google, okay, it's gonna be HTTP request. That is port number 80. Okay, so it will directly go to the Google server and fetch the web page and come back. The same thing will happen here. If it is sending 80, then it is responsibility. Okay, if it is, that is what equal. And if it is another thing, if the traffic is port number 22, port number 22 is not equal. Okay, so if the any package that is port 22 is coming and it is not equals to 22, it is going to deny that. That is not equal. Okay, this is the few things we have to understand when we are giving this one. Okay, now what I'm going to do, I'm going to give you some commands which I have to write that one. Okay, so let me write on this one. Good evening, Prakash. Hello,
Good
Prakash.
evening, sir. Good evening.
Why late, man?
No, sir. Little bit late, sir.
Okay, Dine. Actually, I can't wait because I had some this one. I have kidney stone issues. Okay, that's why. And also the rain is on the way. That's why. Okay. So TCP 192.168.2.0 network. Okay. So it's gonna be its wildcard must be 0.0.0.255. Okay. What is my host? Should not reach 192.168.1.3. Okay. EQ www. Okay. I'll tell you what this one. Okay. So another one is same like this. Okay. I'm going to copy this one. Okay. Paste it here. Here I'm going to use the 192.168. I'm going to block the 3.0 network. 3.0 network. Okay. Should not reach 1.4. 1.4. And here I'm going to change the port number FTP. FTP. Okay. So another thing, to deny 3.1 network. That is 3.1 network. 3.1 network. See, or if you're using a single network, you don't need to give the subnet mask. It will automatically take. Okay. Host 192.168.130. Okay. Equal this one. 1 dot. Okay. So this one 1.3. Okay. So next, another thing. See, control. So I have to shut down 3.2 network. 3.2 network. Okay, I'm going to here using ICMP because I'm going to deny the link. ICMP. Okay, so deny 3.2. Okay, network should not reach 1.2. Okay. So it's a single network, so I don't have to give this one. Okay. 1.2, and if it is ICMP, it is going to be echo. There's no need to give equal because only we have one thing. Okay, control C, control or ICMP. So 3.2 should not reach 1.2. Even replay also. Replay means I'll tell you what is that one. And remaining things permit any permit ID any. See here what will happen. Okay. So look at here. Okay. So what was the first one? So I'm going to open the packet to settings. So look at here. Okay. So I made this. Okay, let me show you what I made. Okay. So here I made this as an HTTP symbol. Okay. So that is 192.168.1.3. I made it as HTTP server, and I made 1.4 as an FTP server. I've just connected, nothing else, guys. I didn't enable anything like that. I've just connected like this. Okay. Only I did the two things like that. Now, as per my scenarios, what I have to do. Okay. So what is the first question? Guys, I
DNAS.
have okay, so I have to deny 145. For example, my ACL, whatever the ACL I'm going to do, it's going to be enter 145 only. Okay, so ACL number will be 145 like that. Okay, so I have to deny 2.0 network. What is the 2.0 network? This is my 2.0 network, and this 2.0 network should not reach 1.3. That is the HTTP server. Means if I ping from here to here, it should work. But if I try to open the website, that is this web page, that is 192.168.1.3, it should not work. Got it, Prakash?
Oh, yes, sir. Yes, sir. Got it.
Got it, right? But the other services should run. But in standard ACL, it's not like that. It's going to block permanently each and everything. Okay. Second, I have 3.0 network should, okay, 3.0, that is whole network. That's why I taken the this one. Okay, a wildcard should deny 192.168.1.4 FTP. That is 192.192. Okay, if any port is request from here to here, that is 21. That's why I use it equal 21. Okay, if I use 21 port, it should, when it reaches here, there are servers in server. We have lots of this one. We have lots of ports is there. For example, see, look at here. We have services DHCP, DNS, all are different ports are available in this server. So what will happen if anything that is equal to FTP, that is port number 21, it will come here, it will check the 21. If it is equal to 21, whatever the packet which is come from this network, if it is equal to 21, we should block that. Got it? The whole network. Okay, got it, guys?
Yes, sir. Yes, sir.
Got
Yes,
it?
sir.
Next, what is the third one? We have to deny 3.1 network. Where is the 3.1 network? This 3.1 network, okay, host should block 1.3. That is, if this guy, okay, if this guy wants to come here and www, okay, port number 80. So he's using port number 80. Okay, when this guy come to connect here and if he requests for any web page, okay, what I have to do? We have to check whether he is requesting for web page. Web page means port number 80. If it is matches, that is equal, then I have to block the web. Okay, we have to web service. We have to block the web service also. Got it? Next, I have one more thing, that is 192.168.1.1. So have you seen here, right? If you once you send a packet from here to here, what will happen? It's going to share successful, right? That right? If it is showing successful and failed, right? Correct, right? That right? Whenever you try to ping from one to one, what will happen? It is going to either it is going to show successful and it is going to see failed. Correct, right? That is
Yes,
what
sir.
the work of ICM. Okay, this ICMP is a protocol which is going to send the message. Okay, whenever the packet is destroyed, it is going to check whether it is reached the destination or it is going to send back the acknowledgement. Okay, if the packet reaches the destination, then it is going to give the successful message, that is echo. Okay, if the package is sent from source to destination, that is echo. If it is reaches the destination, there is echo replay. Got it, right? For example, if you ping from here to here, if it is successful, it is echo. If you try to ping from here to here, if you didn't get it, that is the echo replay. Got it, right? That is what the ICMP protocol is going to do. Okay, this is the one of the protocol. ICMP is the one of the protocol which is used to check, which is going to give me. It is a messaging protocol. Okay, Internet Component Messenger Protocol. It is going to give the message to the users whether the sended packets is discarded or send it to the destination or the packet was lost like that, whether it is failed or first. Got it? So whatever the message you're going to get here, right? Successful, failed, all this is a ICMP. Got it, Prakash, Pawan? Got it,
Yes,
right?
sir. Yes, sir.
Now, one more thing. Imagine if I didn't add this one, what will happen? What will happen? 3.0, 2.0, and 2.0 and 3.0. There is some issue with this one only. What about the remaining guys? 1.1 and 2.1. If this guy send a package, it should reach, right? Start, right? If this guy send a packet to this one, it should reach, right? What happens if I didn't give permit any like that? First, it will check the first statement. If it isn't match, second, it will go third, fourth, fifth. If it is not matched to each and every one, it will be implicitly denied. Implicitly means that packet will be dropped. If it is design match to each and anything, then it is automatically dropped. That's why at the end we are going to give the permit. Okay, remaining the permit means permit IP any means if any of this IP address or any of this statement didn't match, then then the other packets or other packet should be allowed. Got it right? Got it right? Always remember, guys, when you are giving, you have to give this last option, because there are lots of other PCs or servers in the network where they are interacting with each other. If you didn't give properly, then the whole thing will be blocked. Remember this one. Okay. In standard ACL, what will happen? You can able to add at the end, but if you want to remove in between the middle, it's not going to possible. You have to delete the whole ACL and then you have to rewrite. Remember, so be careful. Okay, be careful when you are doing this one ACL. Okay, because it's very complicated and you have to read it properly and you have to get it know the properly. Okay, now tell me one thing. Okay, where I have to implement the ACL? Either I have to implement an R1, R2, or R2. Which one? Prakash.
I think R1, sir.
Okay, good. R1, because each and every packets are going to the destination 1.3. Correct, right? 1.3. Now tell me which interface. Either I have to put it on serial port 0 to 1 or fast Ethernet 0/0.
Serial port, sir.
Why? Why cannot put on the fast Ethernet?
Both
Yes,
is
good.
possible, sir. I think.
Good. Very good. Both is possible. Yes, very good. It is possible. Because it's an end, right? I can do here also. That's not a problem. Because there is no other routers after this one, right? Correct, right? Either I can able to give the access hyphen group. Okay, 145. If I give 145 out. Okay, where? Okay, out means if it is entering to the this one what router, that is in. If it is leaving the router, it is out. So I can give it on serial port 0/2/1, or I can give it as here also. That is fast Ethernet 0/0 also. Very good, guys. Very good. So I can able to, since this is an last router, I can give it on this port or this port. But remember, in the future, in the company, this guy is someone else has come and have installed the another router, that is R4 like. Okay, then you have to remove from here and you have to give it here. Please remember this one. You have to delete all those things and then you have to. So whenever you're adding anything new in the network, you have to check what are all the alteration is going to happen in the network, and whether it is going to affect any ACL or any other protocols. Remember this one. This is very important. Okay. Always remember, when you join some company like that, first thing you have to know is your whole network. It should be in your mind. It's like Indian map like that. Whenever I say Indian map, you should have that imagination. Okay, where exactly Karnataka will come, where exactly Maharashtra will come, each and everything. That should be inside your head only. The same thing when you are inside the CCNA, and if you are working in some companies like that, you should have the map of each and every network where it is coming. Okay, got it right. That's why whenever if you are a fresher and when you enter into the company like that, they are not going to give each and every access. They are going to give some basics access for about 6 months like that. Then they will upgrade you to L3, L2, L1 like that. Got it? Because they want you guys to know the map of their network. Got it?
Yes, sir.
Yes,
Okay.
sir.
Okay. Okay. Fine. We'll do one thing. Let's go and do some lab, man. Okay. So I'm going
Hello,
to.
sir.
Yeah. Tell me, Prakash.
Sir, one more thing is there 192 Denny 192.168.1.1 to 3.1.
Okay. You wanted to know 1.1 to 3.1. Uh,
Yes, sir.
which which service? Now I'm not in the standard AC. I'm inside this extended AC. Whether you wanted to stop the ping, whether you wanted
ICMP,
to.
sir. Yes.
Yes, you can do that. Yes, you can do that. You can, but what will happen? Which is your destination, Prakash?
3.1, sir.
Okay, then what you have to do? Either the same thing. Either it is the last one means either you do ACL on here or here. It's depend on you. If there is any other router here, then you should do it here. Or any other ACL was implemented on this router, then you have to do like. Got it? Any confusions here?
Nothing, sir. No.
No, got it right? Prakash and Bhuvan,
Yes, sir.
remember this one. When you are doing the ACL, first thing is very important is know about your okay whole network. Second thing, okay, remember common sense. Okay. So whenever someone trying to implement, see, imagine this will happen. This was happen for me. That's why I'm telling you. I was working in ACT where this is, for example, what happens. This is my Vijayanagara router. This was my Rajaji Nagar router, and this is my Nagarwagi router. They extended to Kengere and given the something. Okay, this is going to affect. If I added any ACL here, this is going to affect. Whenever they installed and they are making this series with this port up. Once they made this port up, you have to at that time you have to change the ACL. If you're given the series port here, if you give for some series like that, you have to change that one and give to inside the pass Ethernet 0/0. Okay, that is access hyphen list. That is 145 group access hyphen group out. Got it? Got it. So whenever there is a implementation happens in the network, you should sit and you have to do it properly. Otherwise, it is going to destroy the whole network. Got it, Prakash? One.
Yes, sir.
Okay, this
Yes,
is
sir.
the real time scenarios, guys. Please remember this one. Okay, I suffered in this one. That's why I'm telling you. Okay. Okay, we'll do one thing. We are going to do some lab here. Okay. So I've just connected and I've given some IP address, I think. Let me see. 192.168.1.3 like that. Just given the IP address to this one. Let me go to this one. Oh, I didn't give for FTP server. Okay, sorry. So what is my IP address? That is 192.168.1.4. Okay, subnet mask. Okay. This is my default gateway 192.168.1.100. Okay, it's done. Okay, so let me try to send a packet. See, this is what ICMP. See, I see. I tried to reach from 1.1 to 2.1 because it's failed. The packets were dropped here only. Okay, so it's the same thing. I'm going to do it from here to here. Okay, it's failed. Let me check, guys. Either I've given the IP address to each and everything. I don't know. It's I've done this long back. Um, here, one here. I think each and everything is given. Just okay, given. Okay, but let me try from here to here. Any routing protocol I have already successful from here to here. Successful from here to here. Okay, I think I didn't give any routing protocol. That's what the packet is. Yes, I didn't give any routing protocol. Okay, so let me go to this one. Enable config t host name R1 and and okay config t router RIP. Okay, version 2. Okay, what all the networks are connected? Network 192.168.1.0, correct?
1.0.
Okay, another network 10.0.
10.0. Sir.
Okay, um, /8, right? /8. So 10.0.0. Okay, and let me go to R2. Okay, CLI enable config t host name and config t. Okay, router IP version network 192.168.2.0 network 10.0.0.0 network 11, right? Yeah, 11.0.0.0. Right, it's done. Going here, there's 3.0. Let me check here. Set the proper configuration. Okay, CLI and config t host name R3 and config t router or IP network 192.168.3.0 network 11, right? 11.0.0.0.
Yes, sir.
And it's done. Great. Good. Very good. Successful. Successful. It's failed. Successful. Okay, let me go through some things and let me see. Okay, first before that one, I have to enable something. It's an HTTP server. Let me check whether it is enabled or not. HTTP, where is HTTP? This one. Okay, HTTP both are on. Okay, I'm just using HTTP. Okay, it's on. Okay, second one, but all the other things HTTP except HTTP, FTP. Okay, 1.4 FTP. Let me go here. FTP services. Where is FTP? FTP. FTP. It's on. I have this one. I can use this one itself. No, I'm going to create the new one. Okay, so it's on. Add. Okay, so account is already there. Okay, so I'm going to add. Remove this one. I'm going to add the new information is selected. Services. Okay, I'm going to give something like username, maybe password, CCNA. So I'm going to give all the permissions. Read, write. I'm going to add that. So remember, guys, Naveen and CCNA. Okay, it's already there. It's done. Let me go again and check these services. Okay, Naveen and CCNA. It's done. So first thing first, okay, what is the first procedure? I have to check 192.168.2.0 network. 2.0 network should not hit 1.3. 2.0 that is www. Oh, that is HTTP. Okay, let me go here. Where is the web browser? Okay, here. So let me see. 192.168.1. Yeah, I'm getting a reply. Okay, so let me check the another one. Here, desktop. One 192.168.1. Yes, I'm getting the reply here. Okay. So before configuration, I'm just cross-checking what all the things is going. Okay. Next FTP, how to get 192.168.3.0 network should not reach 1.4. 3.0 network means this one. Okay. This network should not reach, right? Okay. Let me go here. Okay. Command prompt FTP. What is my IP address? 192.168.1. It's taking time dot FTP 192.168.1.4. Disconnected from FTP server. Why it's failed? So 192.168.1.4 192.168.1.7. Fine. It's fine here. And what happens here? Desktop 3.1, 3.100, 192.168, 3.1, 3.1. Okay, fine. So try to ping from here to here. Successful. So try to ping from here to here. Successful. So try to ping from here to here. Failed. Why? Why it's failed? From here to here. It's successful. Why? What happens here? 763.0. It's fine. It's correct. 11.0.0.2. It's correct. The packet is pinging from here to here. No, it's not pinging from here to here. Wait, what happened? Version 2. Auto IP. 10.11. It's given here. Yes. Here live. 168. 3.0 network. Oh, forgot to give version 9. That's taken version 1. Config T. Router. Version 2. Link. Now we got it. Small mistakes. So now from here to here, yes, it's successful. Okay. So let me check from here to here. See what I did the stupid things is I've just created the version 2 version here and I created the version 1 here. Since there is no authentication or it uses broadcast message 255, 255, 255, 255. Here it's going to use 255, 255, 255, 254. Here you use multicast. Here it use broadcast. That's why it's not working. Okay. Now let me ping from here to here. The ping is working fine. Okay, but the issue is I have to check the FTP. That is 3.0 network. Let me check here whether it is working or not. Where is the command prompt? Yep, FTP 192.168.1. Username is, what is the username again?
Naveen, sir.
CCNA.
Naveen.
Naveen, no, CCNA. Sir.
I think N I've given this one. Naveen. CCNA. CCNA. Naveen. Naveen. CCNA. Okay, see, look at here. I'm inside the FTP now. Yes, correct. Now I'm inside the FTP. See, there is no C drive available. So you can't you are not going to see the password. You have to, once you type, it's going to automatically take, but it's not going to visible for you. Okay, that is one of the best advantages in Cisco like that. Okay, so now I'm inside the FTP now. Okay, so the same thing I'm going to do it in this one. This piece is like, okay, let me check whether it is working or not. There is the command prompt. Okay, FTP 192.168, 168.1 dot username Navi, password CCNA. Okay, yeah, I'm inside this one FTP server now. Okay, so what I'm going to do, the third one is also working from as of now. Okay, so what is this one? FTP. Now I have to check the echo message. Echo message means 3.2 should not reach. What is the this one? 3.2 should, okay, 1.2, okay, that is 3.2 should not reach 1.2. Okay, let me see. 3.2 should not reach 1.2. Successful, it's happening. But echo replay from here also, if I'm sending this one, yes, it's successful, it's happening. Okay, it's successful. Successful. Now the main thing. Now I have to implement the AC. Okay. So as per our concept, each and everything is going to 1.0 network. So I'm going to implement on this one. Okay. So what I'm going to do, first I'm going to write an ACL here. So enable config T access hyphen list. Okay. So I'm going to take the number 145. Okay. So first I have to deny as per the instruction. First we have to write the deny. First one is TCP because I'm going to use the www, that is 192.168 dot 2.0 network. Okay, its wildcard mask is 0.0.0.255. Okay, should not reach host. What is that one? 192 dot 168 dot 1.3 server, that is HTTP server, that is www. Enter. Okay, that is some issue. Okay, I didn't give equal. Okay, eq. Okay, next another thing, access hyphen list 145 deny. It's going to be TCP only. 192.168.3 dot, sorry, 3.0 network. So it's a whole network. So I have to give the wildcard mask 0.0.0.255. Should not reach the host, particularly host, that is server 192.168.1.4 means equal FTP. Done. Next, again, access hyphen list. Oh, sorry. 145 deny TCP. Okay, www is done, FTP is done. Okay, third one 3.1. Okay, so TCP single host. So I'm going to 192.168.3.1 should not reach the host 3.1 should not need 1.3. That is host 192.168.1.3. If you, what is this one? Port www. You can give www or directly you can give the port. That's not a problem. Okay. Next, again, I'm going to take this one only.
Hello, sir.
Yeah, tell me, Prakash.
Sir, what is equal, sir?
See, the equal is an operator when I'll write first, Prakash, just a minute. Okay, I'll get confused. Okay, just a minute. Okay, so deny TCP, ICMP, okay, ICMP, okay, host, just a minute. I've taken here on the deny ICMP, host 192.168.3.2, okay, host not reach 192.168.192.168.1. Again, the ICMP only. So 3.2 should not reach 1.2 hyphen replay. So any replay is not replay. Okay. Again, access hyphen list 145. This is very important. Remaining things should be permit. Permit IP any. That is any source, any destination. Okay. And yeah. Now tell me, Prakash, what you are saying something. Okay.
Sir, whatever you wrote now, so could you please explain that, sir, one more time?
Which one?
You wrote something from R1, right?
Oh, this one.
Yes, sir. Yes, sir.
Okay. So here I'm going to the same thing, man. Here what I return. See, look at here. I'm going to deny one thing. First one. That is I'm going to deny 145 is my ACL number. Okay. So TCP is the port I'm going to here because the www come under TCP. Okay. So we have lots of ports. Okay, which come under different types. For example, see. So inside the TCP you will have www. Okay. For example, let's say another thing like what are all the things? HTTP. Let me take this one. Okay. So there are three things. Okay. So TCP, UDP. Prakash, you know TCP, UDP, right?
Yes, sir.
Okay. So the ports which come under TCP is HTTP, Telnet, FTP, okay, etc. But when it comes to the UDP, we have DNS, DHCP, okay, SNMP, and TFTP. But when it comes to the ICMP, we have ping and trace. Okay, these are all come under these things, correct, Prakash? Okay.
Yes, sir.
Okay, now what I'm going to do here, I'm going to block one thing, that is 2.0 network should not reach 1.3, correct? So the meaning is 2.0 should not reach 1.0. So for example, here, for example, I'm going to the 2.0 network. 2.0 network should not reach 1.3. So if I try to ping from here to here, Prakash, in standard ACL, what will happen? It's going to block each and everything, right? But there are n number of service inside this one, right? FTP is there, that is this one, HTTP is there, DNS is there, DHCP is there, correct, right? Correct, right?
Yes, sir.
I wanted to block particularly one network, correct? If this packet request for port number 80, that is www, when it come to this ACL like that, it is going to check whether whatever the port you are requesting for the destination network and destinations, this one, not only it will check the destination IP address, it is going to check the destination, this one port. If it is equal to port number 80, then it is going to deny. If the same guy is try to ping this FTP server, okay, it is going to deny. Okay, but For example, let's say that if the same guy here, if this guy wants to ping from this one, port number 80, that is www, that is web service. Okay, it is going to work. Here, the only the port it was docked is 21. 80 is not equal to 21, Prakash, correct, right? Then it is
Yes,
going
sir.
to, yeah, 80 is not equal to 21, then it is going to allow. If this guy sent an web request, then 80 is equal to 80. It's true, right? This matches, right?
Yes, sir.
Equal.
Yes,
Then
sir.
it is going to, yeah, then it is going to block it. Because here we are working with the port numbers, where if it is equal means if 80 it matches this one, then it is going to deny. If it is not matches, then it is going to allow. Because even though my source and destination address is same, means destination address is this one, we has to check the port number, whether he is going to use the HTTP, whether he is going to use the FTP, or whether he is going to use the DHCP. Like we are only blocking a single service only, Prakash. Got it?
Yes, sir. Yes.
Got it, right? Okay. Okay. Now tell me one thing. Where I have to enable this one? Either I have to enable on their service port, or I'm going to enable this one. This is like in. Okay. So whatever the packets which is coming inside, this is called in. Whatever the packets leaving means this one, leaving this router, that is called out. Okay, let's say I'm going to do it on fast ethernet 0/0, then I have to give access hyphen group 145 out. If I'm doing it on series port 0/2/1, then I'm going to do it in access hyphen group, okay, 145 in. Got it? Whatever the packets coming inside this one, this router, it is going to be inside. Leaving means outside. Got it? Got it or confused? Prakash,
Sir,
go on.
FA 0/0 is the inside, right?
It's not like that, Prakash. I know, I got it what you're saying. If any packets is coming into the router, that is inside. If any packets leaving, whether it is leaving from this network or this network, okay, that is out. Yeah, as per you, it's 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 going out of this router, but it is entering into the switch network. But it is there leaving the router, right? That is what it's out. Got it?
Yes, sir.
Confused? Bhuvan? Hello?
Yes, sir.
Got it, right?
Yes, sir.
See,
Got it.
if it is coming in, if it is coming to the router, it is inside. If it is leaving, if it is leaving from here or here, it's out only. It's outside only. Okay, remember this one, sir. You may ask, sir, it is coming inside the network, right? No, 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 not like that. It is when it only works at the router. If it is coming means it's inside. If it is leaving means it can be outside. Okay. So what I'm going to do? I'm going to implement that one. Okay. Let me go to this router. Okay. So again, config T interface. It's fast Ethernet only, right? 0/0. Okay. Let me cross check. Yes, fast Ethernet. Let me check that fast Ethernet 0/0. Yes. Okay. And config T interface fast Ethernet 0/0. Okay. So IP access hyphen group 145. I am going to group all these things inside the 145, and I make it is as what? Out or in? Hmm? Guys,
Outside. Outside.
out,
Outside.
out. Remember, out. It's
Sir, only out or outside, sir?
outside only. It will take. Okay, in or out, anything you give, it will be configured. Okay, actually is outside. It will take out. Okay, so it's done. Okay, show IP access list. This is what if you want to check what is the things you have configured, you can check it here. So you have taken 145, that is more than 100 to 199. So the router will get to know that you are using extended ACL. Everything is done. Let me check one after another. So what is the first thing? 192 2.0 network should not ping 1.3. Let me go here. Let me go to one web.browser. Let me check 192.168.1.3. Previously you got a message, right? Nice. Correct, right?
Yes, sir. Yes, sir.
See, now the request timeout. Okay. So I'll do one thing. I'll check whether the FTP is working or not. So command prompt FTP 192.168.1. It's working. Now we got it, Prakash.
Yes, sir. The ping is working, sir. Then
Yeah, ping is, of course, it's going to work. Let me end this one. Oh, I mean, say this one, right? So command prompt exit. Okay. Yeah. No, it's not going to work. Just a minute for FTP, right? And it should work. And exit. Exit. We can't ping from here to here. Oh, this one, right? Huh? Guys, this one only, right? Yeah, it's successful. The ping is happening.
Yes, sir.
Got it. Got it, right? Okay. What is
yes,
the second? Sorry, the second one. 3.0 network should not get 1.4. Okay, where is 1.4? This is 3.0 network. Whole network. Okay. Let me go to command prompt. Here, command prompt. Okay. Exit. It's not working. It's not working. Okay. Or I can use quit also, right? QUI. It's done. Okay. So now I have to take one thing. FTP. Just a minute. FTP 192.168. See, request timeout. Yes. Let me check another this thing. 3.2 also. Command prompt. It's not going to work here yet. Okay, fine. FTP. Okay. FTP 192.168.1.4. Now anything else? Let me check the ping option whether it is going to work. Yes, 100% work. And here also, yes, it's working. Okay. Let me check the remaining things. What is the third one? 3.1 network. We have to deny 1.3. That is this web page. Okay, only the 3.1 or this one? Okay, 3.1 network. Okay, this one. 192.168. It's not working. Go here. 192.168.1. It's working. Prakash got it. Bhuvan got it. Guys.
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
Now, what is the remaining thing? 3.2 should not ping 1.2 and reply also. 3.2, 1.2. Okay, 1.2. Where is 1.2? Sorry, where is 3.2? This one. Okay. Command prompt. Ping. Which one? I forgot. 192, 168. 1 dot. 1 dot. Hey, hey, 1 dot. 92 dot 168 dot 1 dot. See, host is unreachable. Okay, I'll do traceat also. CERT traceat 192.168.1 dot. Let me check. See what's the message I'm getting. I can go up to 3.0 network. I'm going to 3.0 network. From there I can go to 11 dot. From 10.0.0.1 I can go up to here only. But from here it's not allowing me. Got it now, Prakash, Bhuvan. See, stopping me there only. Okay, so the same thing I'm going to do it from here. 1.2 to 3.1. Ping 192.168. Yeah, I'm getting the triplet. Just a minute. Here is at 190, 192. Which one? I totally forgot. 3.2, 1.2, 3.2, 3.2, 3.2. Where is the 3.2? This one is the 3.2. Okay, I have to be in setting 1.2. I go replay. Okay, so I am not even getting the replay also. The packet is not even getting the replay, means the ICMP itself is not working. See, previously you got a
Sir,
replay. Yeah, tell me.
sir, last two I didn't get, sir. 3.2 or to DNA 102, sir. Echo or echo reply.
No, I didn't reply because there is only this one. Which one? Which one? This one. Echo
Sir,
and echo
sir,
reply.
yes, sir, I didn't get that two, sir. Echo or echo and echo reply, sir.
Echo and
I didn't understand.
echo replay, right?
Yes,
Okay.
sir.
See, in echo and echo replay, what will happen means, okay, here in the echo, what will happen? It will go to the destination. Okay, for example, 3.2. Where is 3.2? It's here. Okay, 3.2 and 1.2. 1.2. Okay, what will happen in echo? It will try to reach the destination, but the destination is unreachable. Correct? Correct, right? That is what the message I get, right?
Yes, sir.
But echo replay means in when this 3.2, when this 1.2 or 3.2 anything, if they send a packet, it's not, that packet is not even moving from this destination. So you got the two things in this one, right? Okay, the echo request, okay, the echo request, it is going to send from source to destination IP. The echo replay is going to get the response from destination IP to source. Okay, echo means it is going to send, that means it is going to send the request from this source to this destination. That is, it is going to send the request. Okay, that is echo. Okay, echo replay means it is going to response. Echo replay means it is going to response from this destination to source. Got it, Prakash?
Yes, sir. We can check it, right, sir? No.
Yeah, we can check it. See here. So what will happen here? So if I send a request from here to here, okay. Sorry. Just a minute. It will do up to 30 this one. That is the last host it's going to trace. What is the message you are getting? You are getting a replay, Prakash, but you are getting a replay from where? What is the replay it's giving? It's only request, echo request is sent to the source to destination. But where is my destination? That is 10.0.0.1 is my destination. It is my actual destination, right? But it is reaching up to this destination. That is what echo. See, look at here. Got it or confused? Bhuvan Prakash. My
No,
destination.
sir.
Huh?
Uh,
Prakash.
Confused, sir.
See, Prakash. See, what is my destination network, Prakash? What is my destination IP I have to reach?
1.2, sir.
1.2, correct, right? 1.2 is my destination replay. I have to get for replay from here, correct, right? But where exactly till it is reaching?
Till it is reaching 10.1, sir.
Here only, right? This interface only, right?
Yes, sir.
Correct, right? This up to here it can able to reach. That is what the echo message. From here onwards, it's not going to reach. The request is which is sent from source to destination. It only reaches up to here. When you send a packet message from here to here, it will only reach up to here, but it is not going to enter this one. That is what the echo request is sent from source to destination IP, but it is not going to it has to ping from here to here, but it is only reaching up to here. Okay, then the echo replay it's like whatever the message you're going to send, it is not even going out of this network. See, that's why the request timeout is coming. See, previously what I done, I pinged from 3.1. Okay, I'm getting a replay from 3.1. That is my 3.1 means whatever the packet I'm sending from here, that is 1.2 to 3.1. Where is the 3.1? See, 3.1. See, I'll show it in the tracer also. Okay, is that one?
So we are getting from 3.1.
Yeah. See, I'm going to trace it. TRACERT trace it. Let's say 192.168.3.1. See, I can able to reach. See, it is going from this one to 1.0 default gateway. From here, it is going to reach 10.0.0.2. From there, it is reaching 11.0.0.2, and it is entering into the directory. It is 3.1. But when you do the trace it for 3.2, it's not even moving from this point. See, it's not going to reach the destination. It is going till here, but it is not going to reach the destination because I've already blocked the destination. Request timeout to reach the destination. Got it, Prakash? Hello? 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 See, whatever if I'm sending a request from here to here, okay, it is not reaching the destination. Okay, but when the same replay it is coming from here to here, it's not. Echo is like a message, means it is like a ICMP message where we are going to set a this one. See, look at here. If I send a packet from here to here, see, this is the successful. Successful means Once the packet is reached, this ICMP is a protocol which is going to send an acknowledgement message whether it reaches the destination or not. It is understandable. It only give this message is only for us usernames. That's why I use ICMP messages. Okay, it is like an acknowledgement message for the users like that. When we send echo here, okay, we are going to ping. We are going to send a packet from here to here. Okay, since it's not going to work because it's going to block it from here only. But the same thing we are going to do it from here to here. It will going to block from here because it's not going to read, because we already given the command that you have to stop the echo and also the replay also. Echo means from source to destination what we are sending the data, that is called echo. Replay means the acknowledgement what we are sending from destination to the same source, that is what we call echo replay. Got it right? There one dot.
The only ping, sir, in 1.1 to 3, sir, 1.1 to 3.1, sir.
Successful. Okay, see, look at here. I'm going to do the reset here. 1.1 to 3.1. Ping 192.168.1.1 I'm getting a replay.
No, sir. No, I want to deny, sir, that 1.1 to 3.1, sir.
Okay, then you have to do one thing. 1.1 to 3.1. Correct, right? Then you have
Yes,
to
sir.
write the another command. Okay, 1.1 to 3.1. Correct, right? 1.1.
Yes.
Then you have to deny the same thing. Okay, control C, control D. See 1.1 to 3.1, right?
Yes, sir.
That's it.
No, sir. 1.1, sir.
1.1. It will do the same thing, man. Oh, you want to reach from 3.1, right? Then you do write it crossly. That is just a minute. 1 dot.
No, sir. I want to deny from 1.1 to 3.1, sir.
That's it.
Sir, how to write in command from, sir? Sorry, in CLS.
ACL, you have to again log into config key. Okay. Again, you have to do access hyphen list.
In R1 only, sir. I have to do in that
Yes.
command.
You have. Yeah, you have to do it in R1 only. 3.1,
Sir.
right? You can see 3.1 means you have to do it here on this router. Either you do it on serial port 0/2/0 or fast Ethernet 0/0. You guys do one thing. Try to do experiments, man. Then only you will get to know ACA. Prakash.
Sir, for example, sir, I did only echo, sir. Then how reply will come, sir?
Echo means only it is going to reach the source to destination. It is going to block that one. Okay. But here it's going to show unreachable, right? Correct, right? So here you're showing that where it is. You are not going to get a replay, Prakash. That is, host is unreachable. Instead of giving host is unreachable, you are going to get a message saying that here, let me show here. I think it's here. 3.2, right? This type of message you are getting. You will get a replay. See, you will get a replay. But here you are not going to get a replay. You are not even getting a replay. Look at here. There is, see, request timeout is coming. You are not even getting a replay.
That is echo reply, right?
Yes, that is echo replay, Prakash. You are
Okay.
not
Echo means you can get reply, but it shouldn't reach, right?
if it is shouldn't reach till when it is going to reach, that is going to get the replay for that. Echo replay means it is not even get any replay.
Okay.
Anything else, guys?
Nothing, sir. Nothing.
Can I stop the class here?